Already you are familiar to the Thales theorem. You know how to just solve numerical problems because you are going to simply write the ratio and you are going to substitute. We will just do one sum. Okay. See, here, since you are in 10th level, mostly whenever this Thales theorem, it is a frequently asked theorem. Based on this question, you will be getting some problem riders based on this. We will do one rider. Okay. For example, the rider states, in a trapezium, ABCD is the trapezium. The line segment joining the midpoints of the non-parallel sides is parallel to the parallel sides. You are going to prove this. Now, construction, what you are going to do, you produce this. Since they are non-parallel sides, at some point definitely they are to meet. Let us name the intersecting point as P. Now, you know these two are parallel sides. We are going to prove this line joining the midpoints of the non-parallel sides is parallel to parallel sides. So, we name it as X and Y. So, you are going to prove XY is parallel to AB and XY is parallel to CD. Okay, lines parallel to the same line are parallel to each other. So, even if you prove this line is parallel to one line, obviously it will be parallel to the other. Now, according to the Thales theorem, this is a line drawn parallel to this because they are the parallel sides of a trapezium. So, you are getting one proportion PD by DA should be equal to PC by CB. Now, DA is nothing. If this is X, this is also X because this is midpoint. If this is Y, this is also Y because this is midpoint. So instead of saying DA, you can say X plus X, that is 2X. So this is PD by 2X will be equal to PC by 2Y. 2 will get cancelled, giving you PD by X is equal to PD by Y. Now, PD by X equal PC by Y. So, now, your Thales theorem states if a line is drawn parallel to one side of the triangle, it divides the other two sides in the same ratio. Converse is, if a line divides two sides of a triangle in the same ratio, that line is parallel to this. Now we are going to make use of the converse. Since PD by dx equal to PC by cy, DC is parallel to xy. So, DC is already parallel to AB because they are parallel sides of a trapezium. So, that means in a trapezium, if you are joining the midpoints, this line will be parallel to the parallel sides of the trapezium. Now, one more problem we'll just do it. This is a very simple problem. We'll do straight away. It's a complicated problem. Now, see, I'll just explain the right hand. This ABC is a triangle. AD bisects the one side of this triangle, that is BC. This point is D. O is any point on the bisector. Now, BO is joined, CO is joined and produced to E and F respectively. OD is produced so that this OD is equal to X dx. So, OD is produced, that is the line bisector. This is like median only. Median is produced so that OD equal to dx. You are going to prove AO by OX, AO by AX equal to AF by AB. Okay. Now, once again I will explain the problem. ABC is the triangle, AD is the median, O is any point on the median, BO and CO are joined and produced to E and F respectively to meet the other two sides. OD is produced x so that OD equal to dx. You are going to prove AO by OX, AO by AX equal to AF by AB. Now, construction, join this. Now, this is equal to this because it's given. This is also equal to this because it's given. That means, in this quadrilateral BOCX, these are the two diagonals which bisect each other. Only in the parallelogram, diagonals bisect each other. So, BO is parallel to CX. CO is parallel to PX. So, this is just a part of the same line only. So, BO is just a part of BE. So, we have said BXCO is a parallelogram. Now, you want to prove AO by AX is equal to AF by AB. AF by AB. Now, AO by AX, AF by AB. Now, this is parallel to this because it is nothing but extension of these parallel sides. So, as per the basic proportionality theorem, AF by FB will be equal to AO by OX. Now, you need, see, AF by FB. So, if you reciprocate FB by AF will be equal to OX by AO. If you add 1 to this, FB by AF plus 1 should be equal to OX by AO plus 1. So, FB plus AF will give you AB. When you take LCM, AB by AF equal to OX plus AO. That will give you AX. AX by AO. Now, you have to prove AO by AX. So, once again reciprocate. There you will be getting AO by AX equal to reciprocate. You will be getting AF by AB. See, once again I will explain this one. ABC is the triangle, D is the midpoint, and AD bisects BC. It is produced in such a way, you are taking any point to go on this median, you are producing BO, CO to meet the two sides at E and F respectively. We are producing this so that this OD segment is equal to dx. O point can be anywhere. And you are going to prove AO by AX is equal to AF by A. Now, since this is equal to this given, this is equal to this, that means in this quadrilateral, these are the diagonals which bisect each other. Obviously, it is a parallelogram. In a parallelogram only diagonals bisect each other. Now, coming to this triangle, this is just the extension of the parallel sides of the parallelogram. So, this is parallel to this. If you take AF by FB is equal to AO by OX. Reciprocate, you will be getting FB by AF is equal to OX by this. Add 1 to both the sides. If you take LCM, FB plus AF. FB plus AF will give you AB. by denominator. If you take LCM, OX plus AO will give you AX, AX by AB. We are going to prove AO by AX is equal to AF by AB. So reciprocate AF by AB will be equal to AO by AX. There we come to the conclusion of this proof actually. So Thales theorem frequently it is asked, and normally instead of problems only writers will be given for proving purpose.